Our next presenter is Max Kolomoyestev, who is the Director of Product Management for StarWind. Max, it's all you.
Thank you. Thanks for having me here. So I was watching the start of the event and realized that a lot has been said already about hyperconvergence in general and about one of the flavors you can do that from the first vendor. So I'll really try to keep it short and maybe focus more on the discussion than on presenting the software itself. And you already heard from Scott about why hyperconvergence and what benefits it brings. So now here is our way of doing hyperconvergence, our way of doing the secret sauce. And our main focus is resiliency and flexibility of the IT infrastructure. So we don't think that one size fits all. So we have multiple building blocks. So it's not only hyperconvergence, but a bit more than that. And to see where we are coming from, I just wanted to show a brief timeline of our company. So originally, StarWind as a technology started in 2003. This is not even on this slide because it wouldn't fit on the slide. In 2009, we spinned off from the parent company, focusing on storage completely. And this was the year when we released first hyper-converged storage solution for Hyper-V. And it was long before the word hyper-converged was even used in technology. We just called it native SAN. And in a few years, major vendors started doing hyperconvergence and invented a new term for that. And in 2015, we stopped doing just software and started doing turnkey solutions for our customers, including hyper-converged appliance. In 2016, we expanded it with storage and backup appliances, so you can follow the 3-2-1 backup rule and keep your backup data separately, and also have dedicated storage for the applications which demand the most performance. And in 2017, our main goals are RDMA-enabled connectivity, which we already have as we speak. Then we added a transparent cloud tiering to Amazon and Azure for primary data as well as for backup data. And we're also releasing all-NVMe hyper-converged appliances for most performance, and also adding all-NVMe storage arrays which operate with NVMe over Fabrics protocol. So now, a little bit more details about how we do hyperconvergence and what are the components we use. So it's pretty much standard that people use Intel CPUs in their compute platforms, and Intel Flash also proved to be very reliable and very fast. We are really glad to work with Mellanox equipment to provide our RDMA-enabled interconnect inside the appliance and also to the outside world. And finally, we added the StarWind Hardware Cloud Gateway, which is just the size of a drive and fits into any industry standard system. And it also allows transparent and secure tiering or replication to any existing cloud service provider. Software-wise, we use standard hypervisors, industry standard vSphere, Microsoft Hyper-V, and we're also adding Zen server support. And to complete this solution with a disaster recovery, we add Beam Availability Suite, so customers can experience sub 15-minute RTPO for their applications and data. And finally, from the storage management side, we do support StarWind vSAN as data mover, or it can also be VMware vSAN or Microsoft Storage Spaces Direct, depending on the scenario. These can even be combined. So our main product is StarWind's hyper-converged appliance. And when we designed it, we wanted to focus on smaller businesses. We didn't really think about web scale, thousands of nodes, and simplified IT in huge data centers. We thought about small companies who typically still have lots of servers running non-virtualized applications, lots of complexity, lack of backup, lack of centralized storage, and huge overheads. They were wasting money to pay consultants who still supported that system and never had budget to go for an enterprise-level solution. So we decided SMB needs hyper-convergence. And this is how we started, and later on we expanded this solution to fit not only smaller businesses, but a lot of bigger businesses also accepted it as a robo solution because effectively, as our customers previously said, it's a fire and forget solution. So you just start it, configure it, and if something breaks, you just get an alert and you replace the drive, it resynchronizes automatically, and your virtual machines continue running. So it's not that you need to service it, watch over it, and babysit your system. It's a fully self-sustained hyper-converged appliance, and you just need 2 nodes to get a complete, highly available cluster. It scales further. You can scale up and you can scale out. So you can add more storage or more compute independently. And it is really aimed at easy integration in existing or new environments, because for each appliance we sell, we provide free deployment services, allowing our customers to migrate their existing workloads, helping them with that, checking all the best practices, and making sure that when customer migrated, everything runs smoothly and failover works properly, so they can relax and stop having that midnight nightmare about their IT infrastructure going down. Now, a part of our availability is based on our architecture. So we do not just scale out using web scale. We do a grid type scale out. So basically every node in the cluster is interconnected with another node, and we keep at least 2 or 3 copies of each virtual machine or application in the cluster. So it allows us to have really good performance because virtual machine has at least 2 or 3 nodes to run on and maintain data locality. And we really focus on data locality for maximum performance because we put a lot of data in distributed RAM caches and distributed flash caches. So accessing local data is a top priority for us. Even if we go over the network, yes, it is RDMA. Yes, it offloads all the overhead from the CPU, but still it is slower. So we try to keep all the data local and consistent to the application. And as I said, it also provides very good resiliency. So any other hyper-converged infrastructure will fail if you remove 1/3 of the servers. So 1/3 fails and the infrastructure goes down. With StarWind, you can lose 50% of the infrastructure without actually losing the cluster. And even beyond, if you lose more than 50%, the cluster will still be operational, but with limited service. So even if you start recovering virtual machines from backup and you have, let's say, 30% of your hosts up, you can still recover the virtual machine and run it on the remnants of the cluster while engineers are fixing the environments in case something very, very bad happens. Now, I mentioned earlier that one size doesn't fit all, and our idea is to provide building blocks for your IT infrastructure. And yes, hyper-converged appliance is the main building block, but for some scenarios where a customer wants to grow his data or customer needs most performance for a particular application and that application needs lots of storage, you need dedicated storage. So think about it. Big data applications, then big data itself doesn't go hyper-converged. It still maintains dedicated storage and dedicated compute for processing data. It's slowly moving that way, but still the problem of good performance across the board is still there, and we address it with very fast and very resilient storage appliance. It integrates with existing hyper-converged appliance nodes in the same cluster, doesn't cause any licensing problems. So let's say with traditional scale out, you add one more hyper-converged node and you have to license it. And you add one more and you have to license it. And you realize you just need more storage. You don't need to pay for additional hypervisor licenses or additional backup licenses. So why bother? In this case, adding just storage here allows you to just pay for more storage. Also, it does support all modern protocols. So it's a unified storage array with all the RDMA-enabled protocols like SMB Direct, ISER, and even NVMe over Fabrics, which is in experimental mode now. And finally, good hyper-converged infrastructure can have a DR solution integrated, but you need to store the backups and all the cold data separately. The 3210 rule says that you need to have at least 3 copies of your data on 2 different media, one of them offsite, and have 0 errors when trying to recover an application. So the backup appliance aims to save your data either elsewhere in a different data center in a different state. It can even be hosted in the cloud as a virtual alternative, but the main purpose is to have an extra copy of the data and also allow quick restore should anything bad happen. So it's not just spindles for high capacity, it's also flash, which can restore an application and run it directly from this appliance should you need it really quick. And to finalize the stack we provide, we offer support not only for StarWind in the appliance, no, it's support for the entire stack. So let's say you purchase StarWind HyperConverged Appliance and you get support for hardware, for the hypervisor, for storage, and as well as for backup. And StarWind becomes a single point of contact. So we never offload hypervisor or hardware support to a third-party vendor. This will all be performed through StarWind. And this means that we get faster support from vendors because we are already pre-certified and qualified to submit level 3 support requests without all the, have you checked the cable, have you tried to turn it off and turn it on again. And this way we make sure, first, we get fast support. Second, we never get any finger pointing from the vendors. You know that from most of the scenarios where you have 2 or 3 vendors in one infrastructure and network blames the storage blames the hypervisor, and customer is not happy. Customer just needs his problem solved and his applications back up and running. And this was main point we tried to address with our single point of contact support. And also, when you get the entire stack from StarWind, even if it's the backup appliance and the hyper-converged appliance, should anything bad happen, you have an engineer helping you not only to restore from backup and then another engineer helping you to bring your hyper-converged infrastructure back up and running. You get one person who knows both in and out and will help you the whole 9 yards. Finally, I wanted to talk a little bit about the features our appliances provide altogether or even one of them at a time. I mentioned earlier that StarWind's hyper-converged appliance is fault tolerant. So we not only replicated active passive, no, the replication is always active, and we make sure that data and all caches are coherent between the systems. And this way, even if you decide to use the fault tolerance feature, you can be 100% sure that your virtual machine will fail over with zero data loss. Also, we do unified storage. So even if you want to connect something to the StarWind HyperConverged Appliance cluster, let's say your existing compute infrastructure or even another vendor's node. For example, we had a case where a customer wanted data migration between his StarWind-based infrastructure and SimpliVity-based infrastructure, and we provided external storage. This was also a possibility. So connecting external resources is possible and supported. Now, scale up is a thing which really differentiates our approach in hyperconvergence, and ability to add resources individually instead of just adding nodes is critical if you have data growth problems or you need high performance storage added to the cluster without adding all these extra nodes. And finally, we do provide all the data efficiency tools like deduplication and compression. We do have our own 4K inline deduplication as well as 32K offline dedup for backups. And it is software defined. So whenever we update the appliance, all the new code also makes it to the deduplication and compression features. It works a little bit faster on updates than the hardware brother. Finally, snapshots are not just done on per LUN level or per infrastructure level. We do provide per virtual machine snapshots, and we also make sure that snapshots don't occupy your precious primary storage in the appliance, so they can be easily offloaded to cold storage like backup appliance or let's say any other storage tier which has more capacity and better dollar per gigabyte rate. And finally, cloud storage tiering. I mentioned that StarWind's HyperConverged Appliance and StarWind Backup Appliance do have an integrated hardware cloud gateway, and this allows us to make some very interesting things with hyperconverged infrastructures. For instance, you can have all-flash local storage and have a cloud tier to expand your capacity. And in this case, whenever you need more storage, you can really do atomic expansions of per gigabyte in the cloud and get really good economics. So previously, Scott showed two lines. One was how your requirements, and another line was how much you paid for the actual hardware. And what we do, we allow you to choose how much you pay depending on how much you consume with on-premise infrastructure by adding a transparent cloud tier to that.
Max,
okay, so that's it. Thanks for inviting me.
We have some questions from the audience. Are you ready?
Yeah, always ready.
So one of the questions was, are you doing any kind of deduplication? But you are. You mentioned that towards the end of your presentation. So you're doing deduplication and compression, correct?
Yeah, it's 4K inline for the primary data, and then for the cold data, we do 32K post-process.
Very good. How far does StarWind scale? And the question is, what's the maximum number of nodes, but how far can StarWind scale in a hyperconvergence scenario?
So as an appliance, we can scale to different limits. So I would say that with current management, I feel comfortable scaling StarWind to approximately 16 to 18 nodes. And if we use vSAN from VMware or the Microsoft Storage Spaces Direct, we inherit their capacity limitations.
Got it.
And we're coming out with our own management for Hyper-V storage, so we will have much higher node limits in scalability in approximately 3 or 4 months.
Okay. One of the other questions we have from the audience is about the hardware side of things. Now, you're available hardware and software, or primarily software, correct?
Primarily hardware.
Primarily hardware. That's what I meant to say. Sorry, I misspoke. Primarily hardware. The question is, can you use off-the-shelf SSDs, or do you require an enterprise-grade SSD? And that's the question that the audience is asking.
So typically, enterprise SSD is somewhat a requirement if you need 24/7 availability, but we do have a technology right now which allows users to get commodity consumer-grade SSDs and use them for primary storage. The only thing is that right now we're still evaluating if this brings the desired level of service if you need to replace the SSDs. But all in all, our log structuring technology allows to eliminate all those spot burns on flash storage. So effectively just writing across the whole board of SSDs dramatically reduces the wear on them. And if you maintain 2 or 3 extra SSDs as hot spares, that would be really comparable to any enterprise-grade all-flash solution.
So the next question was, the person says he's not sure if you missed it, but what brand of hardware are you using for the appliance?
So right now it is StarWind branded hardware, originally coming from Dell OEM. But as we developed it, there is almost nothing left from the standard server, maybe except the chassis in the motherboard.
Very good. Where was it? Oh, tell us a little bit about the person wants to know a little bit about your ability to integrate with AWS as a sort of an interface to the cloud as well.
Right. So right now there are two features working for that. One is simple AWS replication. So we do have StarWind in AWS, and you can spin up an instance and use that as a disaster recovery target for your primary infrastructure. This would be one scenario. And another scenario is that our appliance can have an optional cloud gateway, and that cloud gateway goes right into the drive bay. And on the other side of the gateway, you have an Ethernet wire. And it allows you to see a disk in the system and just offload data to that disk, included in tiering, included in vSAN scenarios, in Microsoft Storage Spaces Direct scenarios, and even in StarWind scenarios, and transparently offload all the cold data wherever you like. In this case, Amazon or Azure.
Next question is, can you run multiple hypervisors on the same cluster? So VMware and KVM, for example.
Well, I would say that we can do it, but will you like it? I'm not sure. I mean, we can definitely do that. Let's say you have a 4-node cluster, two of the nodes running VMware, 2 of the nodes running KVM, and we can support that. The question would be how to migrate the resources between KVM and VMware. We can convert the virtual machines, migrate the storage, but if it's something which needs to instantly migrate from one hypervisor to the other, I'm not sure there are tools available to do that yet.
Got it. That makes sense. I mean, most of the time, we get the question about mixing and matching hypervisors a lot, and most of the time the answer is, sure, anything's possible. That doesn't mean it's a good idea.
Yeah.
So
like you may not like the result.
Right. Got it. Ben, I think that's all the questions we've got right now. Thank you very much for being on the call. Max, thank you for being on the call today.
Thank you. Thank you for your attention.